Hi, the GMAT41's channel members, subscribers, and viewers. You are welcome to the GMAT41's channel. In this mathematics tutorial class, we are going to deal with inverse variation. This is part 2 of our variation class. You will recall that in the previous mathematics tutorial class, we treated direct variation. Please, if you are yet to take that lesson, kindly do so before you proceed with this particular class. It's going to help you to appreciate what you are going to learn further in this inverse variation class. What is inverse variation? What are real-life applications of inverse variation? And how do we solve problems on inverse variation? This will be covered in this particular class. So once again, I say, welcome to this class. We start first by getting to know what inverse variation is. Just like direct variation, it's important for you to know that inverse variation also relates to quantities. But the only thing here is that the relationship is opposite, just like the name goes, inverse. So we define inverse variation as a type of variation that relates to quantities such that as one of the quantity increases, the other quantity decreases. Or as one of the quantity decreases, the other increases. So you see there is this opposite relationship between these two quantities. So this type of variation is called inverse variation. In real life situation, inverse variation can be found in relationships like maybe you have number of people working on a given portion of land. Let us assume that maybe you have a portion of land to be cleared. Are you getting me right? Okay? So you have bushes and it is to be cleared. Now, the number of people working on that portion of land, let's assume to clear it off, will be inversely proportional to the time it takes for them to clear that portion of land. Okay? What do I mean by that? You can think of this, maybe if it takes 20 people to clear a given portion of land in, let's say, 5 hours. 5 hours, okay? If the number of people increases, let's say, from that 20 to thereabout 40, okay, the time it will take them to clear that portion of land is going to reduce from 5 hours because the number of people working on that land has increased. Okay? Therefore, the time it will take them to finish clearing that land is going to do what? Decrease. Think also, if the number of people working on the land decreases, if it decreases, let's say from 20, now it's reducing to 10. We expect that the time it will take them to clear that portion of land will increase from 5 hours up. Let us say maybe there about 10 hours. So you can see that the relationship is inverse, opposite. As one of the quantity increases, the other decreases. How about this relationship? Maybe you talk about the speed that a car takes to cover a certain distance, okay, and the time it takes that car to cover that distance. So we are looking at the relationship between speed and time. That relationship, once again, is inverse. Why do we say so? Now, if you have a given distance, let's say the distance is 20 kilometers, all right? A distance of 20 kilometers. Now, if a driver driving a car decides to increase the speed of the car, let us assume that, okay, the driver drives at 50 kilometers per hour, and the time it took the driver to cover that distance is, let's say, 30 minutes. Okay, 50 kilometers per hour to 30 minutes. Now, if the driver increases the speed of the car to, let's say, 100 kilometers per hour, you will agree with me that it will take a lesser time. Okay, the time will reduce from 30 minutes to cover that particular distance. Why? Because the speed increased. The speed of the car increased. So the time it will take to cover that given distance will decrease. How about the driver decides to reduce the speed of the car from 50 kilometers per hour So let's say 25 kilometers per hour. Okay? Because the driver reduced the speed of the car, you would agree with me that the time it will take to cover that distance will increase from 30 minutes. The time will go beyond 30 minutes. So you see that the relationship between speed and time is also inversely proportional. So dear friends, you can think of other inverse proportional relationship or inverse variation relationship, and please make use of the comment box below this video lesson to write some other examples of real life application of inverse variation. Remember the main point: as one quantity increases, the other will do what? Decrease. And like I mentioned, under direct variation, I told you how important the study of variation is, because there are several scientific laws, okay, based on variation. And so you want to take variation studies seriously. Once again, we are treating inverse variation. Just a quick reminder, like in chemistry now, we have one of these gas law called Boyle's law. Boyle's law is an inverse relationship. Are you getting me right? Relating pressure of the gas inversely to the gas volume. What about Graham's law of diffusion? That law that relates the rate of diffusion to the gas density or to the gas molecular weight is an inverse relationship. So you see that understanding scientific laws, all right, is also traceable to this type of variation that we are treating inverse. Now let us move on into the mathematical, all right, analysis of inverse variation. We shall start once again by taking x and y as two quantities, and then we assume that x is inversely proportional, or x varies inversely as y. If I tell you that x varies inversely as y, how do you establish that mathematically? Please come with me. Let us do this analysis on the board. Remember, x is inversely proportional, or x varies inversely as y. That statement is written mathematically as x, then we fix our sign of variation of proportionality sign. Take note, this is inverse. Therefore, it's going to be 1 over. You know, mathematically, the term inverse is translated to mean 1 over that other quantity of interest. Here we are saying that x is inversely proportional or varies inversely as y. So it's going to be x varies, then inversely 1 over the second quantity, y. So you see in inverse variation we use 1 over. That's the main point. Are you getting me right? So if I tell you that the pressure of a gas varies inversely as the volume of that gas, it's simply written as P, sign of variation, then 1 over V. Graham's law of diffusion of gas. If I tell you that the rate of diffusion of a gas is inversely proportional to the square root of the gas density, then we can say that the rate of diffusion, if I use R for it, is, put your variation sign, 1 over, then square root of density. So I want to believe that with this, you understand the meaning of inverse variation. Now, you look at the way they are written. This x is numerator, this y is denominator. Are you following, right? So you can see the opposite relationship here. As x is increasing, y will be decreasing. Or, as x is decreasing, y will be what? Increasing. Now, from our previous class, I explained already, you don't solve anything with this variation sign. So what do? Kick it off, and then introduce equal to with a constant, which will multiply this 1 over y, so that if you have k times 1, you are going to get k over y. So this equation is very important. Are you getting me right? When dealing with inverse variation, it's something of this kind. So you want to take note of it, okay? You want to take note of it. And of course, when a problem is given to you, once you establish this format of equation 1, you solve for k, are you getting me right? And get the relationship connecting the variables. Suppose k is 5, for example. Maybe for a particular problem, then your x will be equal to 5 over what? Y. Does that make sense? And this k is your constant of variation or proportionality. It does not change, like I explained in our previous class under direct variation. Now, there is something I would like us to do. Are you following, right? I did same under direct variation, making k subject to the formula, the constant of variation, and then let's see what it's going to be. For k to be made subject to the formula, you have to cross multiply first. And if you cross multiply, you'll agree with me that x times y will be equal to k. And I told you in mathematics, all right, when a quantity is equal to a constant. It gives you room to write that quantity in its initial and final state. This is why I told you to make sure you take our previous lesson on direct variation. I took my time to explain all these concepts so we can move on straight in what we want to deal with under inverse variation here. So this is equal to constant. It implies that we can write x1 times y1 equal to x2 times y2. And of course, this can continue equal to x3 times y3 equal to x4 times y4. You know, as you move on in your study of science and engineering, you would see this concept in some aspect of subject or courses you're going to meet. Okay? So you want to take note of this. For example, our Boyle's law is something that looks like this, just that we use pressure and volume, okay? P1 V1 equal to P2 V2. So you want to take note of this. Like I said, I established this equation just because of some other aspects of your subject, physics and chemistry, to be specific. In mathematics, we are going to limit ourselves to this usage of equation 1. Is that okay? But I want to take note that in inverse variation, we can extend that formula to something like this, okay? Where you have initial value of that quantity being equal to final value. Alright guys, this is pretty much about what you should know about inverse variation. The next thing is for us to pick questions and solve to see how we apply inverse variation problem, okay, mathematically. We're going to solve questions to see what you are expected to know about this formula. Let us move on to our very first question, number 1. Alright, so we've got the question. T varies inversely as the cube of R. When R equals 3, T equals 2 over 81. We are required to find T when R equals 2. We've got the options here. Because this is Jamb question, but it doesn't matter. It's actually a 1 plus 1 stuff. Cass said, just once you understand the background of this variation, problem is over. This is inverse variation connecting T to R. But the relationship is such that T varies inversely as the cube of R. So you want to take note of this. And this is written mathematically as T varies, then inversely 1 over the cube of R is R raised to the power of what? 3. And of course with this, we could just have T to be equal to K divided by R what? Cube. As simple as that, you know. Remove this sign of variation, introduce equal to, and your constant of proportionality. I've decided to use K. So once you've established this, you see something like this equation 1, okay? The problem is solved. Go on and pick the first initial conditions. Are you following right? R is equal to 3. You know, when R equals 3, I'm going to write that out. We have that the value of T is equal to 2 over what? 81. Substituting this into this equation, it's going to be that for T, we're going to fix 2 over 81. And that's going to be equal to K divided by what? R. Because we don't know the value of K at this point. Our constant of proportionality, we don't know that. Now the value of R is 3. We are going to raise it to power 3. And so from this, you know we have 2 over 81 equal to K over 3 to the power of 3. I'm not going to waste time on this. 3 to the power of 3 is 27. So let's just go straight on. If you have 27, and then you can cross multiply here, you know that. So 2 over 81 equal to K over 27. If we cross multiply, this would mean that, let me continue here. This would mean that our 81K will be equal to 2 times 27. Now there's something I don't want to do here. I don't want to multiply 2 by 27. It's going to, you know, get the number to 54 for me, and I don't want that. I'd like to leave this because I know somehow, okay, that 27 can divide 81. So for that reason, I choose to leave this in this form. Are you following? So that to get my K, I will divide through by 81. So this is going to be 2 times 27 all over 81. And then the K is going to give us, now watch, I know that 27 can divide 27 to give you 1. And then 27 can divide 81 to give you 3. Are you following right? So that this would give us 2 over 3 left as the value of K. So the constant of proportionality is 2 over what? Over 3. Now that we have obtained the constant of proportionality, the equation, the relationship, the formula connecting the two variables here, T and R, will simply be written as, take note of that relationship will be T equal to, let's come over to this equation. Are you getting me right? This formula. fix up the value of k while maintaining the variables t and r cube. So that's going to be 2 over 3. 2 over 3, if I remove this k and fix 2 over 3, that over 3 as a denominator of that numerator is going to come downward. Are you following, right? Watch, 2 over 3. That 3 will come down to this r cube. So we're going to have t to be equal to 2 all over 3r cube. So this is the relationship connecting the variables. Now in this relationship, we move on to find the value of t when r is equal to 2. So I'm going to now write when r equals 2, we don't know the value of t, so the implication would now be, visit this relationship now. Let me indicate this guy. Take note. Let me call this maybe equation, let me call it equation A. It doesn't matter, you can call it anything. Go to that equation A, fix up the value of r, then solve for t. This is going to be 2 all over 3 times, our r is 2 and it is raised to power 3, so it's going to be 2 to the power of 3. And then this we have is going to give us 2 times, okay, that's 2 divided by, we have 8 here, you know, 2 to the power of 3 is 8. So that this is going to be 3 times 8, 3 times 8. And what is the implication? Therefore, our t is equal to, let's solve these ones. 2 can divide 2, giving us 1. 2 into 8 is going to give us 4. So that this will become 1 over 3 times 4, which will give us 1 over 12. It's going to give us 1 over what? 12. And of course, this is the value of our t. Can actually go to the option and you find out that the correct option to this question is B. I hope you enjoyed this, right? So you see, the truth of the matter is solving variation problem, inverse variation is a simple one, okay? It's a simple one. Just follow the format and that's all. Apply the implication of all mathematical terms used. Like in this case, we have that the r there is cubed. T varies inversely as the cube of r. So that when you're solving, you're going to have r to the power of 3. And work on anything that you're asked to work on. Use the initial conditions to get the constant of proportionality, the constant of variation. Then you have to, if you wish, establish the relationship connecting them. Very important, because sometimes your examiner could just ask you, what is the relationship, the equation or the formula connecting the variables? That is why in my classes I always like bringing out that guy after getting my constant of variation. Then from that you move on to the second condition and that's all. Are you following? Find the unknown that you are asked to look for. So you see, this is pretty very simple. Okay? I have solved this in the way you expected to know it. But the truth is, respecting Jamb straight on in terms of how you attack this question, you see, these guys could have been solved easily. The fastest way of solving this is remembering this relationship. Okay? The initial conditions multiplied, this and this. But remember, this is going to be what? Cube of r. So the fastest way to attack this, if it were to be in exam hall, okay, talking about Jamb specifically, is going to be something like 3 raised to the power 3, which is 3 cubed, because the r term is cubed, times 2 over 81, equal to t2, which you don't know your final t, times the cube of this, 2 raised to the power 3. If you solve that, you're going to get that your t, which you are looking for in this case, is equal to 1 over 12 as shown on the screen. So that's the fastest approach if you were to find yourself in real exam hall. But I've decided to do this in the normal way you are expected to know this. I hope you enjoyed this video lesson, right? This is pretty much about inverse variation. Very simple. Okay? If you have any question, please make use of the comment box below and I'll be there to respond. If you have not joined our learning community, below this video lesson you have the join tab. Tap on the join tab. The GMAS 41's packages will appear, alright? Select whichever of them that is convenient for you. Become a channel member. Support GMAS 41 in order to follow up with our step-by-step coaching. Remember, physics, chemistry, mathematics here is redefined. Okay? I'll be seeing you in my next video lesson. In our next class in mathematics, we'll be dealing with joint variation. You will not want to miss the class. So, hit the subscription button, turn on the notification bell so that once I upload that content, you will be personally notified. I'll be seeing you in my next video lesson. Remember to take your studies seriously.